All right, welcome back. We got some more miscellaneous geometry problems for your enjoyment and edification. We just finished going over rules, and remember where you find answers to the multiple choice questions. As always, those are here. And copyright notice, all of these problems are from GMAT Prep free software. By the way, make sure you notice that difference too. On our forums and on our study hall, we can use the problems from the free GMAT Prep software, but not from paid question packs. Paid question packs are a no-no. Because GMAT has very politely and diplomatically asked us not to use our paid materials at all. So that includes not only the official guides, but also the paid question packs to GMAT Prep. But the free question packs are the mainstay of the forum. Those are actually the most commonly discussed things on the whole thing. So these are all from the free software of GMAT Prep. And with that said, we're going to give you one. Go ahead and try this problem. And don't forget where your multiple choice options are found. They are found here. Give it a shot. All right, at this point you should think about whether you are doing productive things. If you're not, you should pick one of the answer choices and get on with your life. If you, at this point, if you're, in other words, if you're still working at this point, it should be like you have a gun to the back of your head, and you know, if you keep working and get it wrong, you'll get shot. A little bit dramatic, but if you would keep working under those circumstances, then you can keep working. Otherwise, nope. Otherwise, cut it. Okay, we've got Yobami, Badri, Jenny, Roger. And Xenophon, I know you're having issues with your connection. Okay, let's talk about this problem. Does anybody know how can you do this thing without using any algebra? Anybody know? Chat box, any ideas? Remember, when you review these problems, one of your main themes, unless you are already using them frequently, should be non-algebraic, non-textbook methods. So if you've seen, there's a bunch of study hall sessions whose theme is flexible problem solving, which translates into having lots of different ways to solve the multiple choice questions. So, okay, yeah, you do. As far as the ratio goes, isosceles right triangle is the same thing as 45, 45, 90, and that is the correct ratio, although you could, if you forgot the ratio with this kind of triangle, then you're still okay, because you could just use the Pythagorean theorem. But, I mean, all right, well, let's go ahead and look at it with algebra first, then, if no one's coming up with this. There is something that is substantially easier to use. Remember, your goal is to accumulate as many methods as you can. So let's look at an algebra approach first. It's going to wind up being more annoying than what we're going to see later. But, you know, it's all good. Let's take a look. Let's say you want to put a variable somewhere. So as Conchal points out, sides are in the ratio of 1 to 1 to root 2. This is true. So if you are going to use an algebraic approach, which again you certainly don't have to, but it's what we're going to do first here. If you're going to do this, well, you can just let that be x, and that can also be x, and that can be x red too. That's supposed to be a square root sign. I wonder why it doesn't look like one. Yeah, well now it does. Okay. xx and x square root 2. Okay, so what do we do now? Why is it doing that? Strange. We have decided to label in the triangle now. So what's next? And you just got to use the fact that they give you. So what is that, and how do we use it? Yeah, you have to set this whole thing, because I mean the fact, there's basically only one fact that we have to use here, which is that the perimeter is that unholy number up there. So this is the thing that we have to use. So the perimeter is just the sum of all three of these things. So the perimeter is going to be the sum of those things. So the perimeter is going to be x plus x square root 2. So that's 2x plus x square root 2. And that's going to equal the number that they tell you that it equals, because they tell you that it equals that number. Now, what's going to seem annoying about this is that what you're going to notice here is that this is not a multiple of that. Like if you pull out x here, you 2 plus square root 2. But then this is not going to be a super easy division to do. I mean, it's going to be doable, but you're going to have to divide by that term. Make that cancel out. Set that down there. We can't cancel stuff here. If this was 2 plus 2 square root 2, this whole thing would just be 8. But, so compare the terms and get x. I would argue with one word in what Anjal is saying here. So here's what Anjal writes. I mean, this is true, although I think that this word is false, this word right here. It's not really that simple. You have to know what to do algebraically to reduce something like that. Does anybody know what to do? There's a couple ways you can go about this. Let's look at both. Let's see what kind of ideas you guys come up with. I mean, one way you can do this is to just know there's a special way of dividing by stuff like this. If you know what that is, then you can do it. The other way is to remember what the goal of the problem is. Okay, yeah, backsolve is what we're going to do next. Try out answers. That's actually what I was calling for at the beginning as a non-algebra solution. Okay, so one way to do this is what Badri says. So one way you can do this is to simplify this expression. So the way that you divide by something with a whole number and a square root in it is you multiply by the same expression, but with that sign in the middle reversed. So that's going to be 2 minus square root of 2 that you're going to divide by. Because what that does is it creates that special pattern where it's a squared minus b squared type of pattern. So this bottom part is going to be 2 squared minus square root of 2 squared. It's just going to be 4 minus 2 once you have it all, once it's all said and done. The top you're just going to have to do, though. You're going to have to multiply it out. It's just going to be kind of icky. So here you've got 16 times 2 is 32. You've got 16 minus 16 red 2 plus 32 red 2 and then minus 32. And we went off the page there. Because I mean the other 16 square root 2 times square root 2 is 16 times 2. So that's where this 32 comes from. That goes away. That's going to be positive 16 square root 2 over 2. And so that's going to be 8 rad 2 is x. That is that weird thing again. Okay, well, it's going to be 8 square root 2. is what it's going to be. That's going to be x. All right. So that is 2x. I'm looking at what Anjal wrote there. 16 plus 16 square root 2. You could also do that if you have that sort of intuition, although I wouldn't really. That's a thing that does work. That's pretty cool. I mean, it's not really a method, so I don't really want to present it here because you either have that intuition or you don't. But if you do have it, then it's good. Okay, this is x. The thing that we want, though, is not x. The thing that we want is the length of the hypotenuse. So let's just move all this stuff up so that we have one more line to work with. Okay, there. So the thing that we want is the hypotenuse, which is the same thing, times square root 2. So 8 right 2 times another square root 2. So that's going to be 16. All right, there it is. Now, another route that you can go from here. So if you know how to do this, I know that this thing has some name too that you can look up in an algebra book, but if you know how to do this, then it works. And if you have the intuition that Anjal has, that also works. Although another way to go about doing this, so I mean, let's take what we had over here, and let's reproduce that over here and talk about another way to do it too, which is really, this is not as fancy, but it's just make sure that you remember what the goals are. So, I mean, what's the actual goal of this problem? What do we want to find at the end of all this? What do we want to walk away with? Yeah, we don't want x. We want x square root of 2. So what you can do right now, like you don't have to solve all the way for x before you think about that goal. Like what you can do instead at this exact moment is you can just multiply both sides of this by the square root of 2. Because then this is the thing that we want to find. I mean, you can get that expression in there at any point, right? This is the goal. So, I mean, once we have that's exactly what we want, and we don't want to touch it and replace it with other things. So now we know that if we just simplify this, then we're done. As opposed to having to multiply by another square root of 2 at the end. Well, let's see how this works out. I think you guys will be pleased by this. So 16 square root 2, of course. And that's going to be, but then 16 square root 2 square root 2. What's that? This is the square root of 2 times another square root of 2, which is 2, right? So this is just 16 times 2. Anybody see what happens to this? Here's a hint. Like, these are in the wrong order now. We like to have the square root on the right. So let's just flip that around. Ah, look what happens to that. That's pretty sweet. Because now what you have here is just, you can see right away that's just 16. And you don't have to do all that fancy flipping the sign and pulling rabbits out of hats kind of thing. You know, you don't need to know randomly to multiply by this. Because you have goals, again, and yeah, I mean, if you've watched more than 1 or 2 of these sessions, you're probably sick of hearing me talk about having goals. But you can see why it matters, right? Like, you can just think at the beginning, okay, I don't want X. Which is another, especially in data sufficiency, you really want to cultivate that mentality. Because there's going to be a lot of situations where you can't find the simple expressions, but you can still find the thing you want. So this is the goal. So we should just try to make it as early as possible. Because then once we have it, we have it. So any questions about these approaches? All right, now there is another approach which is substantially less work than either of these things, and that is what NL says. Let's take the problem to the next page. Yeah, I mean, what's the tragedy of this test is that there are a lot of people who just forget that there are multiple choices. I mean, what I mean by that, I don't literally mean forget. I mean, of course, they know they have to pick a choice. But they solve all the problems as though there were no answer choices. Like, if there were not choices A, B, C, D, E, then you would have to do something like what's on this page. You know, because you would have to get an answer out of nowhere. But, guys, there are choices. I mean, don't forget. I mean, the fact that there are answer choices puts a whole lot of tools within reach that don't exist in other kinds of tests. You know, because there are answer choices, you can, let me fix that typo. I mean, not all on this problem, but in general, in multiple choice, you can back solve, which means, you know, start from the answer choices. And just see what you can do. You can sometimes plug in your own numbers. You can estimate. You can do all kinds of stuff. Here, we can back solve this. Back solve. That means just throw in a choice, see what it does, and then go from there. Okay, what should we do with these things if we're going to try them? I mean, it's kind of curious to see they didn't do this, because usually when there are 5 numbers, they do this by default, but these are not in order. So the first thing that we should do is put them in order. Yeah. In general, the middle value thing, I think I explained this in one of the many other study halls. But if you really want to be a nerd about game theory and optimal strategies, then the most efficient places to start it's not the middle. It's actually B or D. But that's not the point. The point is it's much more important to start with things that are easy to use. So let me just put that on the board because it's important enough. I mean, this is not really true. Because remember, the overriding concern here is the fact that you don't have a calculator. So middle value is pretty much irrelevant. What's relevant is convenience and not spending a million years doing computation. So you want to start with the choices that are easiest to use in the context of the problem. So, I mean, we have the hypotenuse of a triangle. I mean, let's put these things in order. I mean, how big is square root of 2? The answer we doubt. Well, if you don't, I mean, if you should try choices that you think have a chance of being right. Yeah, it's about 1.5-ish. It's like 1.4. So 4 square root of 2 is less than 2. So 4 square root of 2 is less than 8. So this is the smallest choice. This is the second smallest. This is the middle choice. This is the second biggest choice. And this is the biggest choice. I mean, what I would do is I would just write these again on my scratch paper in order this time. So 4 square root of 2, 8, 8 square root of 2, 16, 16 square root of 2. Okay, now considering that you are going to plug these in for the hypotenuse of a 45, 45, 90 triangle, which values are easier to use here? Yeah, the ones that have the square root of 2, not the whole numbers, no. Because if you think about your default template for a 45, 45, 90 triangle, it has a square root of 2 on the hypotenuse, and it has the whole numbers on the other side. So just keep that in mind. Like if you're going to memorize a template for this, it's probably going to be this one, square root of 2, 1, 1. This is most people's default template. I mean, you can also remember rad2, rad2, and 2, but most people don't bother with more than one template for the same triangle. So if you know this one, then this is easiest to evaluate. And you know we're going to be able to tell too big and too small really easily. So Umar, you might be right, but we'll still be able to easily tell whether we're too big or too small. So if you have, let's say we tried this one first. It's the one, I mean, we don't want to try the extreme values first because those won't eliminate very many things. So if we throw that in there, that's going to be 8 square root of 2, which means the sides are 8 and 8. And so the perimeter is 16 plus 8 rad 2. That's too small. So notice that all of these things and the smaller ones are eliminated too. All right, where do we go from here? See if someone can come up with cool ways to be lazy, in other words, to avoid having to do unnecessary work here. All we got left is B and E. Well, they're actually it's E and B, but it's the second biggest and biggest answer. Someone tell me a story about what's going to happen if I put in 16 rad 2, which is exactly twice as big as 8 rad 2. What is that going to do? If I plug in exactly twice as much as that, it's just gonna, what's it going to do to the perimeter if I make everything twice as long? Like, you don't even have to do the calculations if you realize this. Yeah, everything is just going to be twice as big, right? So if I do E, then everything is just times 2. So that's going to be 32 plus 16 rad 2, and so now that's too big. And so it has to be D. And I mean, depending on where I'm at in terms of timing and mental fatigue and whatever, I mean, I know that I'm done. I mean, if I don't trust my arithmetic, then I might go back and actually verify that it really is 16. But the point is, you don't even really have to. You can just bound it by using easier numbers and then go from there. If you do want to verify it, then let's do that down there in that lower right corner of the screen. If you do plug in choice D, then this is 16. What do you have to do to get the side length? You have to take 16 and you have to do what to get here? You have to divide it, which is a little bit annoying, you know, because you have to do that whole getting the root out of the bottom process. So, yeah, but it's not the end of the world. So you just got to do that. So that's going to be 16 rad 2 divided by 2, which is going to be 8 rad 2. And so is that. So, aha, the perimeter is exactly what I want it to be. It's 16 plus 16 square roots of 2. And I win the game. There it is. So, okay, any questions about this? So, I mean, as usual, the context is geometry, but really it's, as almost always, it's a test of flexible thinking and a test of whether you have multiple ways of approaching these things in your pocket. So that's the point. Also note, with a 45-45-90 triangle, if you forgot this ratio, you're not screwed, because you could just do the Pythagorean theorem, right? You could just 1 squared plus 1 squared is this squared, and you can figure it out. If it's 30-60-90, then you could also figure that one out by realizing it's half an equilateral triangle. And then you win that game too. So let me just show you those in case. I mean, because if you are like me, then you're not going to remember the ratio. So if you forget these things, You forget the ratios for the 45, 45, 90, or 30, 60, 90 triangles. Then, well, for 45, 45, 90, just realize that it's the same. So you can call the two sides that are the same 1 and 1. And then you can just do the Pythagorean theorem to find the third side. So 1 squared plus 1 squared equals hypotenuse squared. And so then hypotenuse squared is 2. So I read 2. That works. Why does it keep doing that to my square root sign? It's so weird. Here. There's the square root sign. Okay. You can do that. If it's a 30, 60, 90 triangle, then what you can do is realize, again, if you know that ratio that's in the window, then great. But the point right now is if you forget that, if you don't remember that it's those numbers, then you can realize that it's half of an equilateral triangle. So you draw the whole equilateral triangle and then cut it in half. So if we make this triangle 2, 2, and 2, then if we cut it in half like this, then those triangles are going to be 30, 60, 90 triangles. So there's your 1 and your 2. So those two things, the 1 and 2, come from the equilateral triangle. And then you can just find the height with the Pythagorean theorem again. So 1 squared plus height squared equals 2 squared. There, you win. So move the exponents. There we go. So height is square root 3. We win. So, I mean, if you have these memorized, then great. But my point is, like, I'm always going on and on and on about how you don't really have to memorize tons of stuff. And this is another example of how you don't. Like, you can just go off of either of these if you don't know them off the top of your head. So it's good stuff. All right. If you have questions, go ahead and type them. Otherwise, how about that? These are, in case anybody's working with a really small screen here, these are fourth roots in the last two choices. So here is, again, don't forget where your multiple choice answers are located. But those last two options, D and E, those are fourth root of 3. Just in case anyone's having trouble seeing the resolution. Give it a shot. Okay, again, you should always be checking yourself with this question, but think about whether you are doing productive things. If you are not, then it is time to pick something that is a thing. And again, make sure you remember, this is a test where you can't not pick things. So if any of you guys are leaving these things blank, we'll wait for you guys for a little bit, but we can't, wait forever because you might not even be at your keyboard or whatever. But, all right, there's still a couple of you guys: Olivia, Roger, Ryan, Sam, Funkmaster Mayhem, and Jenny. Let's go and pick some answers that are answers. Okay, I don't know if those people that I named are with us right now or not. By the way, guys, it's if you are not here, I mean, ironically, I guess the people who need to see this message are the people who are not here right now. But if you do step away from the screen, then make sure that you use this thing right here. This is the away button. I mean, this doesn't change any of the functionality. In fact, if it's clicked, then you can still do all of the same things that you can do if it were not clicked. But it just tells me that you're not here. So that way we're not waiting for people who are not even here to answer the question. So please use that. All right, let's talk about this. So I mean, we'll work out this problem in a second, but remember that there are choices. What's a way that you can do this taking advantage of the choices without having to actually do any, quote, real math, unquote? How can you just take advantage of the choices here? Anybody? You got a diagram. It's a good diagram because remember, diagrams that are not labeled. Yeah, you can look at it with your eyes. And if it's not labeled as not to scale, that means it's to scale. So you can look at it with your eyes. Yes, you can. And you can just estimate. So let's take a look. We want the ratio of T to S. Triangle is actually equilateral, although I mean it's technically also true that it's isosceles. Yeah. But just looking at it, not doing anything fancy, like literally just looking at it. You know, and you don't be above doing things like taking your scratch pad and putting it up to the screen and actually like measuring stuff, because you can do that. I mean, that's actually a thing, right? Because your scratch pad has graph paper on it. It'll have a grid. So if you want to, you can measure stuff. You can totally just use it as a ruler. Totally honorable way to do this. You can measure the length of things on the screen. Very, very doable. So, but if you do this, if you visualize this, you know, if you picture that length, let's make these things two different colors. If you picture the ratio of T to S, I mean, S is about this long if you put it up next to T. Like if you put S over there, it looks about like that. So maybe like that. If you just measure it, that's what it'll look like. So let's estimate. I mean, someone writes here, I mean, this is a true statement, but you guys are being way too conservative here. Like this is true, but you can do a lot better than this. I mean, this is kind of like looking at me and saying, well, I know Ron is older than 20 and younger than 60. Well, okay, sure, but you know, you could definitely be a lot more accurate than that. Let's get a better estimate here, like an actual estimate, not upper and lower bounds, but an estimate. Give me an estimate. Does it look like 2/3 of it? Yeah, it could be 2/3. It looks about like that, 2/3 or 3/4, yeah. So probably around something like, yeah, sure, you could have T, well, S is the one that's smaller. So Wilton, I'm assuming you wrote that backwards. So maybe T to S could be around 3:2. It looks a little bit, T looks like more than 2/3 of that though, maybe like 3/4 of it. So, or if you're thinking 70%, like S is 70% of T. So that would be 10:7. Because 7:10. I mean, these are two decent estimates. So this would be what, about 1.33 something. They're both around 1.3. There we go. All right, that works. This one, no way, right? I mean, this is telling us that t is smaller than s. No. So nobody picked that one. That makes me happy. It makes me very happy that nobody picked A. Because if it says 3 to 2, it wouldn't be a terrible estimate, although S doesn't look like it's that short. Okay, this is just absolutely crazy. I mean, this is more than 5 to 1. It's about 5 1/3. I mean, this is saying t is more than 5 times as long as s. That's crazy talk. So no way. How big is square root of 3? Yeah, it's about 1.7. So, but you know it's less than 2. But yeah, and if you forget these estimates, then one way of thinking about it is this: square root of 1, square root of 2, square root of 3, square root of 4. Like this is 1, and this is 2. So this is going to be about, 1.3, 1.4, is 1.6, 1.7. I mean, that's good enough. It's not actually a linear relationship, but that'll give you a good enough estimate. So, but this is more than 2 to 1. Or you can do, if you know these dates of these holidays. I mean, yeah, I wouldn't remember when St. Patrick's Day was, but I'm not from Boston or anything. So whatever works for you, man, use it. So 4 to about 1.7, yeah, so this is more than 2 to 1. So you're saying, again, that t is more than twice s. Nope. Not reasonable. What about the 4th root of 3? I mean, notice the 4th root is the square root of the square root. So that's 2 to the square root of 3. How big is that? 2 to the square root of 1.7. Well, you're not squaring it unless you mean the whole ratio. What happens when you take the square roots of things like this? Yeah, it's just going to bring it closer to 1. It's not going to be a decimal less than 1 because that can't happen. Like if you ever had one of those really basic calculators as a kid, you have a square root button, you can just keep pressing it and you watch the number go down and down and down, but it only goes to 1-ish. So, because I mean, 1 squared is 1. So if you're going to square something to get 1.7, it has to be more than 1. So this is going to be 2 to 1 point something, where it's less than 1.7. Probably 1.3 or 1.4-ish. But wait a minute, though. We don't really need to be super exact about this, because if you look at choice E, I mean, choice E is 4 to the same number. So this means that again, t is way more than twice s. Nope, not even close. Oh, hey, accidentally finished. There's only one choice that makes any sense, and that's choice D. You can do it. The other choices are all kind of ridiculous. So, I mean, this is a method. And again, a lot of people, especially people who are already doing quite well, 45, 46, 47, 48 in quant, I mean, a lot of the time what's keeping those people away from 50, 51 on quant is that they're not doing things like look at it with your eyes or use your paper as a ruler. For whatever reason, they're just not doing those things. Like, it's textbook methods all the time, which, that's you need to be good at those, but that's not how you get a 51. Can you generalize diagrams to scale? Unless they say not, yes, you can. Like, unless there's a warning that actually says diagram not to scale. Which is why those warnings have to exist, right? The only reason they have to give you that warning is because the default is the opposite of that. The default is that they are to-scale. So there it is. Any questions? Let's see, a couple of people appear to be typing. Okay. Yeah, all right. So let's take a look at this. How can you do this? I mean, the point that I do want to make is that basically everybody should have gotten this problem right. Because all you got to do is look at it with your eyes. So we're going to look at other ways to do it, but make sure that you do not discount the value of this. Look at it with your eyes. Skeptical about the estimate. What are you still skeptical of? I'm curious what you mean by that. Let's see what it takes us to the next page while you're typing. Skeptical. Okay, some delay happened there in the audio. I mean, okay, I'm reading the words here that you're writing. And I mean, I hear you on this. I mean, this is a challenging test, and there are going to be things that are hard. But whether you're going to win this game is going to be a function of where you go from this. I mean, if you look at this and your reaction is, oh, I just wouldn't do it, then you're going to lose. Sorry. That's how it's going to happen. You're going to lose the game. I mean, what you have to do is you need to be like, aha, learning opportunity. Yeah, like, why is it hard? This is what the first thing you need to figure out. And then, how can I develop the appropriate skill? Because I mean, what's weird about this is, I mean, okay. Honestly, it's weird to me that people go from here to here. I don't get it, because people want to just like practice the things they're already good at in review, which honestly is just completely useless. It's totally a waste of your time. Like, if you're already really, really good at algebra, then if you have a choice between reviewing more algebra and going to sleep for a while, you should probably just take a nap, because it probably is going to be worth more in the long run. I mean, the point of review is this kind of thing. This is the entire point. Like, the weaker something is, the more you should study it. I mean, you shouldn't shy away from it for that reason. That's the whole point. I mean, think about other situations. Like, if you were an athlete who was really strong and really fast, but not flexible, you would spend most of your time stretching, not doing even more speed work and even more weights. At least, yeah, you'd shore up the weak points. So this is the point. Yeah, but don't underestimate your own resourcefulness there. I mean, as long as you know what a fourth root is, then you're good to go here. Because remember, you don't need a hugely accurate estimate of this. As long as you know this is less than 2, that's enough to eliminate E. So, okay. Let's look at a more traditional solution to this. Yeah. Okay. Let's look at a... remember, when you're talking about, I mean, first of all, RIT, you should probably write questions in proper English. Yeah, thanks. Second of all, no one cares what the difficulty level is. It doesn't make any difference at all ever. Like, you don't care. Do not care. There is no possible benefit that that could bring you. So don't worry about it. It's a distraction. If you think about it, you'll just do worse because you will have less brain power to think about the problem. So, yeah. All right. The capital lock, the figure is drawn to scale. That's the whole point. That's if they don't tell you it's not, then it is. Okay. More traditional solution here. Well, you can also just pick numbers, right? You can plug your own numbers. Because these ratios have to be the same all the time. So where would you want to start? Would you want to start with a triangle or start with a square? Where would you want to start this? Guys, question number, it doesn't mean anything either. I mean, you could get this thing as problem 1. You're not going to know. So if you guys are even thinking about this, your score is going to be lower because you're thinking about it. Don't think about it. Don't do it. Don't do it. Why would you think about this? Don't think about it. I mean, okay. Let me know if you guys can hear me. A little tech problem there. Okay, so, I mean, I think a lot of the people who are kind of obsessing over difficulty levels are tech people, like software people. And I mean, it makes sense to me that if you're a software person that you would want to understand how the software works. But you really have to realize that, no, it doesn't help you. I mean, it would be like driving a race car and worrying about what's happening inside the engine. I mean, you can't see the engine, so don't worry about it. You know, worry about the stuff that you can see and control. So really the only thing worth thinking about is the problem that's on the screen in front of you and how to solve it. Not any of these other random parameters. Don't think about it. It's not a thing. Okay, yeah, the square, it's going to be easier to find the square because, like, for example, if I picked S to be, I don't know, like 4 or something, then this would be 16, but making this triangle have an area of 16 is going to be not fun. But you can also look at these, right? T is nice numbers, and these things for S, for the most part, are not nice numbers at all. So this is going to be the biggest hint as to what you should pick, right? Because these are nice numbers that you can pick. And then, you know, the purple numbers, you can solve for numbers like these. Because, I mean, when you solve, you can wind up with lots of weirdo numbers like that. It's not really a problem. But you wouldn't want to start with a number like that. That'd be terrible. So let's plug. Let's say that we might as well pick 16 because all of these go into 16. So let's let T be 16. Yeah, those are ratios, Chan. You can't do that. I mean, ask yourself if you could take a 2 to 3 ratio and just call it 4 to 9. Can't do it, right? Because you wouldn't have the same ratio anymore. So, okay, if those are 16, then that's going to be 48. Perimeter, we don't want the perimeter though. What do we want? So this is what we talked about before. This is a half of 16 is 8, where that whole thing was 16. That's going to be 8 rad 3. You can either get that out of the Pythagorean theorem, or you can get it out of the ratios if you have that in your mind. So this area is going to be 1/2 base height. So that's going to be 16, 8 rad 3, half of that. So square root. So 64 rad 3. So then this is 64 rad 3. And that's going to be side squared. That's not supposed to be a slash. Let's get rid of that. There. And so you take a square root of that. That's where you're going to get that crazy fourth root from. Don't need to worry about plus or minus because these things have to be positive. So it's square root of 64 times square root of square root 3. And that's the side. And so that's your 8 square root 3. 14, what are you saying is 14? Not sure what 14 means. 14.3, if you're doing that in your head, then that is impressive. Although I don't. It's going to be smaller than that, though, because square root 3 is less than 1.5. So that's less than 12. But remember, this is not square root 3. This is square root of 3, which might, I don't know what. Maybe you're just doing square root of 3. But you don't need to do that. We have exact ratios here. So you're taking the ratio of these two numbers. So this is going to be, the t was 16, and the s was 8 rad 3. So if you take that ratio, then that's going to be the same. You can divide this by 8 and get this. So that's D. Same. Do it. How else can you do this from answer choices and still not do algebra? What else can you do when there are answer choices? Answer choices. Plug and chug from where? I mean, because this was kind of plug and chug here. So you mean start from the what? Start from where? Well, picking t as 2 is going to be the same as picking t as 16, except for everything will be exactly 1/8 as big. So that'll be just like this. Different method. It's one of those major ones that we listed before. I mean, remember, here's our major non-textbook methods list that we made before. I mean, we got back solving, we got plug in our own numbers, which is smart numbers. We got estimate. I mean, we already did 2 of these things, right? We already did smart numbers, was the thing we did last time. And we already did estimating. What can we try? Well, let's try back solving. So, Romy, that's a cool thought, except for there would be no way to regulate how people are solving the problems. So, unless we could read minds. But I mean, algebra, I'm not a hater. I mean, people are just too one-sided. I mean, there are way too many people who just don't develop any other skills, which is why the emphasis is mostly there. Let's try this. Let's just start from the choices. Start from a ratio. So I'd rather use A and B first because those numbers are not horrifically terrible. So let's just do this. Let's just try if T is 2 and S is 3. Okay. Well, that's going to be, let's make that thing at height. And let's copy these guys over here. My questions are to, well, yeah, I'm not sure what you mean by my questions, but okay. So if you have 2 and 3, then these are going to be 1, rad 3, and 1 and 2. And then this is going to be 3 by 3. So the areas are going to be, the squares area is 9. This area is 1/2 times 2 times rad 3, which is just rad 3. So no, it doesn't work. You can probably also tell that B is not going to work once you realize this, because you're going to have that. You're going to have that. So I mean, the area is going to have something with square root of 3. Like the square area is still 9. And the triangle area will still have square root of 3 in it, so it's not going to be, it's not going to work. Am I against it? No, I just would be personally not capable of it. That's all. That's why I'm giving alternative suggestions, because I just don't have the capacity to memorize things like that. So there's probably other people who are in a similar situation, although I doubt to the same extreme. But it's always better to have backup ways, even if you do have it memorized, because if you forget, then you've got a backup. If you try C, then let's just try using those things for T and S respectively. If you try that, then this is going to be square root 3 and square root 3. Area of the square is 3. This is going to be 2 and 2 and 2 rad 3. 1/2 times 4 times 2 rad 3. That's 4 rad 3. So a lot bigger. No, it doesn't work. If we do D, because I mean, once you do this once, notice it's very fast, because you're just doing the same steps again and again. So if anyone is worried about time, you shouldn't be. So this is going to be square root of 3. So the area of the square is 1 square root 3. And then this is the same thing as it was. Now it's 1 and 1 and rad 3. That's the same area we found in A. So area of triangles also square root of 3. Hey, look, we win. We did it. It worked. It's a thing. There, you get the same area. Cool, winner. So actually, this problem is pretty awesome, because literally every single major non-textbook method works. All of them, all 3. You can estimate it, you can smart numbers it, and you can back solve it. They all work. Pretty sweet. And if you wanted to set this up algebraically, then you would. First, you'd write formulas for these areas. So same thing, draw in the height again. So that's going to be T over 2. That's going to be that same thing times square root 3. And then that's 1/2 times T times T squared. Yeah, 1/2 times T times T squared rad 3. And then that's going to be T squared rad 3 over 4, rad 3 over 4 times T squared. So that's the area of that thing. And then the area of this thing is definitely S squared. And these are areas. Make sure you label things just so that you don't forget what it was when you get back to it. So area of a triangle and area of square. These are equal. So if you set those equal to each other, then that's where this is going to come from. So this and that, you're going to set them equal, which means you're going to be able to take the square root of both sides. That's where the rad 3 is going to come from. These are all positive, so there's no worries about pluses and minuses. That's just going to be s on the right-hand side. And then everything is square rooted, so it's rad 3 over 2, and then times t. And that's going to turn into choice D pretty quickly. So, there. Cool. So you have approximately a million zillion ways to solve this thing. That's pretty awesome. I mean, including all 3 of our favorite non-textbook methods. Wow. Wow is right. Neat. All right, let's try to do another one here. Let's see what we got for you. Well, you try all of them when you review the problem. Absolutely, you should, because that's the point of reviewing the problem. But when you do it under time conditions, of course, once you get something to work, then you should just go with it. So try this. When it's multiple choice, the figures are always to scale unless it says they're not. Data sufficiency, they are not ever to scale because they can't be. So make sure you know that that's a thing. Let me write that in the corner of this. Here, if it's multiple choice, which this problem is not, then the default is to scale. In other words, they're accurate. And then if there's a warning, then diagrams are not to scale. Data sufficiency, on the other hand, there is actually no such thing as a scaled diagram, because it's not possible. Do you guys understand why not? Why isn't that possible? I mean, if you need to pause from the problem for a second, you can. Yeah, that's the point, right? Because there's so many different ways this could look, because these are random angles. So if there was a such thing as correct scale, that would mean there had to be there would have to be unique correct numbers for x and y, and that's not a thing. So yeah, there's no way to capture all the ways this could look. So think of it as a rubber band diagram. Good. Okay, yeah, no, I was giving you guys time to solve the problem. That's why you're not hearing anything. Okay, should be picking something here soon. Okay, there's still about 5 or 6 of you who don't have answers to this. So pick something. All right, let's talk about this. So these are parallel lines. This is a yes/no question. We've talked about this to excess almost in previous study halls, so I'll just throw up the results of it here. When we talked about yes/no questions in previous study halls, this is a summary of what we've talked about, so we'll follow the same sort of thing here. So the key point is getting out of the words yes and no and getting into stuff that you can actually think about directly. So in terms of specifics. So to this question, is the length of PQ less than the length of SR? So let's translate these things. A yes to that means that it is less. So PQ is shorter than SR. Where also you might, when you make your own diagram, you might want to, just make these nice and thick and circle them or something just so you know which ones you're talking about. And no here would mean that it's not. So they're the same, or PQ is longer. So, and you put question marks after these. The point becomes if I can get both of these things to happen, then it's not sufficient. Which is yes/no questions, that's what you're always trying to do, because you can, that's a concrete goal. I mean, you can't try to not get one of these. So try to make both things happen. And if you fail, then that's sufficient. So if you get both, it's not sufficient. And if you fail to get both, then that's sufficient. All right. So, statement 1, statement 2, what you should do just to remind yourself of what the task is, and just so that you don't lose yourself in the middle of the work. Just make copies of these statements next to each of the statement 1 and statement 2. That way you can circle them or you can cross them off. So, all right. They have to be less than 90. And then x is greater than y. So can I get PQ to be shorter than SR? You can, if you think about what this picture is going to look like. I mean, just try drawing extreme pictures. Like if you make this really close to 90, so it's almost vertical, and then you make that not anywhere close to 90. And the angles, this is x is much bigger and y is much smaller, so that satisfies the statement. And this is definitely longer than that, so PQ is shorter. So we can circle this. Now the goal, what's the goal? As soon as we made this happen, now our thoughts are concentrated on trying to do what? Trying to make, yeah, because you can't make them the same. You probably figure that out pretty quickly. Because they're the same, then that would actually make these parallel lines, which would mean that x and y were equal things. So that's not going to happen, because x has to be bigger. But then you've got this relationship, right? If you just think about this, if you just think about how this is going to work, you can notice a pattern. I mean, there's the start of the pattern in that one picture that you drew. So let's look at more of the same pattern. Here's our lines. So if we forget which one is x and y for now, just look at what happens when you make the angle progressively smaller. We just investigate, right? The pattern is pretty easy to see. As soon as you get, the smaller this angle gets, the flatter the line is, which means the longer it's going to be by the time it makes it up there. So smaller angle goes hand in hand with longer segment. Where, remember, you're looking at the angles that are here, 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 here. So if you realize this, then you're going to realize it's not possible to get PQ longer, because this is going to, x greater than y is going to directly imply that the angle on x is the smaller angle. Anyway, the PQ is the smaller segment. So the deal is noticing a pattern, right? You don't need to know this ahead of time. This is not really, I don't think anyone is going to know this as any kind of rule, but you can just look at it and see what it does. You just make it happen. So you got this, you failed to get that, you cannot get both, so this is sufficient. Statement 1 is sufficient. And I think this is the spirit with which you should approach data sufficiency across the board, is just don't be afraid to investigate stuff. Because I mean, there's going to be a lot of patterns that are much too obscure to be rules that you would know, but that are very easy to see if you just toss around a couple of examples and watch what they do. So that's what they want to make sure that you can do. Just look at things and see what they do. As far as statement 2 is concerned, this is just the sum of x and y. So as far as which one is, if we look at the insight that we gained in the last part, what matters here, like what's the thing that matters about x and y as far as determining this question? Like what do we really need to find out about x and y here? Yeah, which one's bigger is the point, right? So that's because that's what's going to make this happen. This is going to be less precisely if PQ is if x is a bigger angle. But we don't know which one is the smaller or bigger angle here. We can just switch these roles. So in statement 2, we don't know. So we can just do it both ways. Like if you have this let's say we just have 60 and 50 and 40. So if you put the 60 there and the 40 there, then that's going to be the same thing as we did in statement 1. So we're going to circle that. But then you can just switch the roles of the 60 and the 40. You can put them like that. 60 is the new 40, as they say. So there. And now it's the other way around. Circle them both. If you want to color code it, that case gives me that possibility. And this gives me that one. So this is not sufficient because we actually got both outcomes. So overall, this is going to be A, like alligator. The angles can never be equal as both. Umar, that's not true because they could be like 60 and 60 or 50, 46 and 46. Or they could, I mean, you can have two angles that are the same and they don't have to be 45 each. They could be the same and be some other number of degrees. So RIT number 2, that's not how these problems work. Because remember how you use evidence in the real world. I mean, if one piece of evidence already establishes something, then there's no reason to combine it with other evidence. And that's how these things work, too. So you don't put the statements together unless you have to, which you only have to if individually they don't solve the problem. So if they do, if either statement alone solves it, or if they both do, then you don't combine them. You only combine them if they're not good enough individually. Okay. Any other questions about this thing? Notice we had to test cases here. There's not really any realistic way to do algebra here. So, this is a thing we also put on the board in some previous sessions. Put it on the board again. For any data sufficiency problem, there's basically 2 kinds of approaches. It's not like multiple choice where you have a million, billion different kinds of approaches. Here you really only have 2, which are these 2. I mean, it's both a plus and a minus. It's a pro and a con. It's a pro because there's never any indecision. Like if one of these things fails, just do the other one. So in this last problem, there wasn't really any way to do textbook methods with this problem. So here, this guy that we just did, there's not really a textbook solution to this. So you just test cases, just draw stuff, and see what it does. This is what we did. So there you go. And don't forget in general, as opposed to multiple choice where you have lots and lots and lots of things that you can do. And so you should be familiar with that whole rundown of stuff that's possible. All right, we got to close up here. It's pretty much perfect timing. It's right at the end time. So we are going to wrap it. Next session is, I don't know whether it's in 2 weeks or 3 weeks off the top of my head. I think it might be in 3 weeks because I think that I am not available at the date that's 2 weeks from now. But check the web page, they'll update it, and they will put the new date up there. And as always, thanks for attending. And good night and good luck.